There is a problem here. Let's discuss it. 150 milliliter of an HCl solution is completely neutralized by 80 milliliter of a 10 sodium hydroxide solution. Calculate the molarity of the HCl solution. 150 milliliter of an HCl solution is completely neutralized by 80 milliliter of a 10 sodium hydroxide solution. Calculate the molarity of the HCl solution. This is the chemical equation. Sodium hydroxide plus HCl, we get sodium chloride plus H2O. You can see on the left hand side 1 sodium, on the right hand side 1 sodium, on the left hand side 1 oxygen, on the right hand side 1 oxygen, on the left hand side 2 hydrogens, on the right hand side 2 hydrogens, on the left hand side 1 chlorine, and on the right hand side 1 chlorine. Now you can see the ratio. To react with 1 mole of HCl, 1 mole of sodium hydroxide, 1 mole of HCl is required. The same way, to react with 1 mole of HCl, 1 mole of sodium hydroxide is required. It's a ratio 1 to 1. We know the molarity and the volume of the sodium hydroxide solution. Therefore, we can find the number of moles in 80 milliliter of this sodium hydroxide solution. Sodium hydroxide solution. We know volume 80 milliliters. Volume 80 milliliters. And molarity of this sodium hydroxide solution is 10 m. Molarity 10. M mean in 1 liter or 1000 milliliters of this sodium hydroxide solution, there are 10 moles of sodium hydroxide. In 1 liter or 1000 milliliters of this sodium hydroxide solution, there are 10 moles of sodium hydroxide. Now we need to find in 80 milliliters of this sodium hydroxide solution, how many moles of sodium hydroxide are there? We can find it in this way. In 1000 milliliters of this sodium hydroxide solution, there are 10 moles of sodium hydroxide. Therefore, in 80 milliliters of this sodium hydroxide solution, how many moles of sodium hydroxide are there? We can find the answer in this way. 10 mole sodium hydroxide divided by 1000 milliliter sodium hydroxide multiplied by 80 milliliters sodium hydroxide. 10 mole sodium hydroxide divided by 1000 milliliter sodium hydroxide multiplied by 80 milliliter sodium hydroxide. We should cancel out units. Milliliter sodium hydroxide, milliliter sodium hydroxide. Then we get 0.8 moles of sodium hydroxide. In 80 milliliters of this sodium hydroxide solution, there are 0.8 moles of sodium hydroxide. To find number of moles, if we want, we can use formula of molarity, M equals N divided by V. In earlier videos, we used this formula. If we want, we can use this formula now also. Now we have found number of moles of sodium hydroxide, 0.8 moles. We know the ratio 1 to 1. I have written this again. Ratio to react with 1 mole of sodium hydroxide, 1 mole of HCl is required. To react with 1 mole of sodium hydroxide, 1 mole of HCl is required. Then to react with 0.8 moles of sodium hydroxide, how many moles of HCl are required? We can find the answer in this way: 1 mole HCl divided by 1 mole sodium hydroxide multiplied by 0.8 moles of sodium hydroxide. 1 mole HCl divided by 1 mole sodium hydroxide multiplied by 0.8 moles sodium hydroxide. We should cancel out units. Mole sodium hydroxide, mole sodium hydroxide. Now we get 0.8 moles of HCl. These 0.8 moles of HCl are in this 150 milliliter of this HCl solution. That means there are 0.8 moles of HCl in this 150 milliliters of HCl solution. Now we can find the molarity, moles per liter or moles per 1000 milliliters. We know in 150 milliliters of this HCl solution, there are 0.8 moles of HCl. In 150 milliliters of this HCl solution, there are 0.8 moles of HCl. Then in 1000 milliliters of this HCl solution, how many moles of HCl are there in this molarity? We can find it in this way: 0.8 mole HCl divided by 150 milliliter HCl multiplied by 1000 milliliter HCl. 0.8 mole HCl divided by 150 milliliter HCl multiplied by 1000 milliliter HCl. We should cancel out units. Milliliter HCl, milliliter HCl. Then we get our answer molarity 5.33 molarity of this HCl solution. That means in 1 liter of this HCl solution contains 5.33 moles of HCl. It is molarity. There's another way to find the answer. Second method. There are two chemical solutions here. One is HCl. We know volume of this HCl solution 150 milliliters. 150 milliliters volume of HCl solution, but we don't know molarity of this HCl solution. We have to find it. We have been asked calculate the molarity of the HCl solution. We have to find it. We know volume of this sodium hydroxide solution 80 milliliters and molarity of this sodium hydroxide solution 10 m. We can take this HCl solution as number 1 solution, and we can take the sodium hydroxide solution as number 2 solution. There's no problem. If you want, you can use we can take HCl solution as number 2 and sodium hydroxide solution as number 1. There's no problem there. Now here we have taken HCl solution as number 1 solution and sodium hydroxide solution as number 2 solution. We don't know therefore we can take molality of this HCl solution as M1. We can take volume of this HCl solution V1. Molality of this HCl solution M1, volume of this HCl solution V1, and we can take molality of this sodium hydroxide solution as number 2, and we can take volume of this sodium hydroxide solution as V2. We don't know M1, molality of this HCl solution. We have to find it. We know V1, volume of this HCl solution 150 milliliters. We know molality of this sodium hydroxide solution 10m, and we know volume of this HCl solution 80 milliliters. Now we can create a equation like this. M1 V1 equals M2 V2. M1 V1 equals M2 V2. We don't know M1, we know V1. We know M2 and V2. We can substitute these values to this equation. We don't know M1, we know V1 150 milliliters. We know M2 10m, and we know V2 volume 80 milliliters. Now we have to find M1. Therefore we have to isolate M1 on the left hand side of this equation. Then this 150 goes to right hand side in this way. Now we should simplify this. Then we get 5.33 m molality of this HCl solution. We got the same answer. Earlier also we found the answer. Molality of HCl solution is 5.33. Thank you very much for watching this video. Please subscribe our channel. God bless you.